National Electrical Code, or NEC, doesn't address or define a subpanel because it's not a formally recognized term within the electrical industry. While electricians and others often use the term subpanel to describe a panelboard installed downstream from a main panel board, the NEC doesn't provide a specific technical definition for what constitutes a subpanel. Because of this lack of a formal definition, the NEC doesn't include specific, dedicated requirements that apply solely to something called a subpanel. Instead, the code provides regulations for panel boards in general, and these regulations apply regardless of whether the panel board is what someone might informally call a subpanel. To understand this better, it's important to clarify what a panel board is according to the NEC. A panel board is essentially an assembly designed to house overcurrent protective devices, like circuit breakers or fuses, along with buses, and it's often equipped with switches for controlling circuits. Panel boards receive power from the main service equipment or from another panel board and then distribute that power to various branch circuits within a building. The NEC contains many rules about panel boards, covering things like their installation, wiring, overcurrent protection, grounding, and working clearances. These rules are found in various articles of the NEC, including Article 408, which deals specifically with switchboards, switchgear, and panel boards. When installing a panel board, whether someone calls it a subpanel or not, it must comply with all the applicable requirements in the NEC. This includes ensuring it's properly rated for the available fault current, that it has adequate overcurrent protection, that it's properly grounded, and that it's installed in a location with sufficient working space. Let's consider some of the key NEC requirements that would apply to a panel board installation regardless of whether it's being referred to as a subpanel. Firstly, overcurrent protection is critical. Each circuit within the panel board must be protected by a circuit breaker or fuse sized appropriately for the conductor ampacity. The NEC specifies how to determine the correct size of overcurrent protection, taking into account the conductor size, the type of load being served, and any applicable directing factors. Secondly, grounding and bonding are vital for safety. The panel board must be properly grounded to the building's grounding electrode system, and all metallic parts of the panel board, including the enclosure, must be bonded together to create a low impedance path for fault current. This helps to ensure that in the event of a ground fault, the overcurrent protective device will trip quickly, minimizing the risk of electric shock. Thirdly, working clearances around the panel board must be maintained. The NEC requires sufficient clear space in front of the panel board to allow for safe access and working room for electricians. The specific dimensions of the required clear space depend on the voltage of the panel board and the presence of any exposed live parts. Fourthly, proper labeling is essential. All circuits within the panel board must be clearly labeled to indicate what they serve. This helps to ensure that electricians can quickly and easily identify the correct circuit when performing maintenance or troubleshooting. Fifthly, the panel board must be installed in a suitable location. The NEC prohibits installing panel boards in certain locations, such as bathrooms, clothes closets, and over steps of a stairway. The panel board should be installed in a dry, accessible location where it's protected from physical damage. It's also important to consider the ampacity of the feeder conductors supplying the panel board. The feeder conductors must be sized large enough to carry the total load served by the panel board, taking into account any demand factors that may apply. The NEC provides tables and guidelines for calculating the required ampacity of feeder conductors. Another key consideration is the available fault current at the panel board. The panel board and its overcurrent protective devices must be rated to withstand the available fault current. If the available fault current exceeds the panel board's rating, a fault current study may be necessary to determine the appropriate protective measures. When installing a panel board in a residential setting, there are some additional considerations. For example, the NEC requires that all 15 amp and 20 amp branch circuits supplying receptacles and dwelling units be protected by arc fault circuit interrupters, or SIs. SIs are designed to detect and interrupt electrical arcs, which can be a common cause of fires. In addition, ground fault circuit interrupters, or GFCIs, are required for receptacles in certain locations such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to protect against electric shock by detecting small ground faults and interrupting the circuit. In commercial and industrial settings, there may be additional requirements for panelboard installations. For example, the NEC may require the use of surge protective devices to protect sensitive electronic equipment from voltage surges. Surge protective devices are designed to divert surge current away from the equipment and into the grounding system. Another important consideration in commercial and industrial settings is the coordination of overcurrent protective devices. The goal of overcurrent protection coordination is to ensure that the overcurrent protective device closest to the fault will trip first, minimizing the extent of the outage. This can be achieved through careful selection and coordination of circuit breakers and fuses. It's also important to consider the ambient temperature when installing a panel board. The NEC specifies temperature ratings for conductors and equipment, and it's important to ensure that these ratings are not exceeded. If the panel board is installed in a hot environment, it may be necessary to use conductors with a higher temperature rating or to provide additional ventilation. In some cases, it may be necessary to install a separate enclosure for the panel board to protect it from the environment. The NEC also contains requirements for the wiring methods used to connect to the panel board. The wiring method must be suitable for the environment and must be properly supported and secured. The NEC specifies various types of wiring methods, including conduit, cable, and wireway. It's important to select the appropriate wiring method for the application and to install it in accordance with the NEC requirements. When working with electrical systems, it's always important to follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment, and following lockout/tagout procedures. Lockout/tagout procedures are designed to prevent accidental energization of circuits while they are being worked on. It's also important to be aware of the potential hazards associated with electrical work, such as electric shock, arc flash, and electrocution. Arc flash is a dangerous phenomenon that can occur when there's a short circuit in an electrical system. Arc flash can produce intense heat and light, and it can cause severe burns and other injuries. The NEC requires that employees provide arc flash protection for their employees. This protection can include personal protective equipment such as arc-rated clothing and face shields, as well as engineering controls such as arc flash barriers. In addition to the NEC, there may be other applicable codes and standards that apply to panelboard installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures. These standards specify the level of protection that an enclosure provides against environmental factors such as water and dust. It's important to be familiar with all applicable codes and standards before installing a panel board. When in doubt, it's always best to consult with a qualified electrical inspector or engineer. They can help to ensure that the panel board is installed in accordance with all applicable requirements and that it's safe to operate. It's also important to keep accurate records of all electrical work that's performed. This includes documenting the location of the panel board, the size and type of conductors used, the ratings of the overcurrent protective devices, and any other relevant information. These records can be helpful for future maintenance and troubleshooting. In summary, while the term subpanel isn't formally defined in the NEC, the code provides comprehensive regulations for panel boards. By understanding and complying with these regulations, you can ensure that panel board installations are safe and reliable. Always consult the latest edition of the NEC and any other applicable codes and standards before performing any electrical work. Remember to prioritize safety and to seek guidance from qualified professionals when needed. The lack of a specific definition for subpanel doesn't diminish the importance of proper panel board installation. All panel boards, regardless of what they're called, must meet the NEC requirements for safety, grounding, overcurrent protection, and working clearances. By adhering to these standards, electricians and installers ensure the safe and efficient distribution of electrical power throughout a building. Furthermore, the absence of a subpanel definition highlights the NEC focus on performance-based requirements rather than prescriptive ones. The code outlines the desired outcomes. They circumflex safety, reliability, and proper functioning of electrical systems. They circumflex and allows flexibility in how those outcomes are achieved. This approach encourages innovation and adaptation to different situations as long as the fundamental safety principles are upheld. Therefore, when working with panel boards, focus on understanding and applying the relevant NEC articles, such as Article 408, and any other applicable codes and standards. Pay attention to the specific requirements for grounding, overcurrent protection, conductor sizing, and working clearances. Consult with qualified professionals and local electrical inspectors to ensure compliance and safety. By following these steps, you can ensure that any panel board installation, regardless of whether it's referred to as a subpanel, meets the highest standards of safety and performance. The NEC is continually updated to reflect changes in technology and industry best practices. It's crucial to stay informed about the latest revisions to the code and to apply them appropriately. Continuing education courses and professional development opportunities can help electricians and other electrical professionals stay up to date on the latest NEC requirements. Ultimately, the goal of the NEC is to protect people and property from the hazards of electricity. By understanding and applying the code's requirements, we can all contribute to a safer electrical environment.